In question 4a, we have to show that the equation tan plus sin x upon tan x minus sin x equals to k can be expressed as 1 plus cos upon 1 minus cos equals to k. So in the first step, we know that the tan x is equals to sin x upon cos x. So we can write it as sin upon cos plus sin. And in the denominator as well, in place of tan, we can write sin upon cos minus sin, and this will be equals to k. Now taking the LCM in the numerator and the denominator, so we'll get this will become sine plus, so as the denominator is 1, so this will become sine cos upon cos, as we'll have to multiply this by cos, so this will also multiply by cos, and then taking the LCM in the denominator as well, so that will become sine minus sine cos upon cos equals to k. Simplifying this, so we can write it as sine plus sine cos upon cos. It is being divided by sine minus sine cos upon cos equals to k. And we can take sine common and bringing in the multiplication sign. So we'll get sine into 1 plus cos upon cos multiplied by cos upon sine into 1 minus cos equals to k. So cos and cos will cancel, sine and sine will cancel. So we'll get 1 plus cos x in the numerator and 1 minus cos x in the denominator, and that will be equals to k, as we had to prove in part A. In part B, we have to express cos x in terms of k. So to express cos x in terms of k, basically we have to make cos the subject. So cross multiplying in the first step, we'll get 1 plus cos is equals to k minus k cos x. And then to make cos the subject, we can take the minus k cos x on the left hand side. So that will become cos plus k cos x is equals to k minus 1. So we'll get cos into 1 plus k is equals to k minus 1. So cos x will be equals to k minus 1 divided by k plus 1. In part C, it says, hence solve the equation tan x plus sin x upon tan x minus sin x equals to 4. Now, in the first step, we have already done that. This can be written as 1 plus cos upon 1 minus cos equals to k. And in part B, we had already made the subject cos x. So cos x will be equals to, so we can write this as 1 plus cos upon 1 minus cos equals to 4. So in place of k, we can write 1 plus cos upon 1 minus cos equals to 4. And as we had already made cos x in terms of k, so cos x will be equals to k, as cos x was equals to k minus 1 upon k plus 1. And k is 4 up here, so we can write it as cos x will be equals to 4 minus 1 divided by 4 plus 1. So that will be equals to 3 upon 5. Once we have the value of cos x equals to 3 upon 5, now we can find the basic angle. So cos inverse of 3 upon 5, so that will be equals to, substituting this in the calculator. So, and we'll have to make sure that the angle is in radian mode. And now taking shift cos inverse of 3 divided by 5, that will be equals to 0.927. And as the domain of x is from minus pi to positive pi, we know that cos is positive in the first and the fourth quadrant. However, so we'll have to make 0.927 in the first quadrant. And as it is till minus pi as well, so we'll take the negative angle as well. So which will be up here. So this angle will also be 0.927. So the first angle will be positive 927. So x will be equals to 0 plus 0.927. And as we have to measure the negative angle as well, so that will be a negative 0.927.